All right, so you're just getting this down to your notes. This is basically where we're going to be headed today. It's just doing a little quick refresher about domain and range, then a little bit of a look at vertex and axis of symmetry. Just bringing back some vocabulary because this is the work that you're going to be doing after the quiz, is just practicing these ideas again. So looking at this example that we have, the first thing that we're finding is the domain. So let's take a look at where this came from. Domain is the possible x values, right? So basically what I'm doing is I'm looking to see at what x value does this graph start. And notice my graph exists entirely to the right of -7. Hence why our domain over here is listed as x is greater than or equal to, because it starts at -7, then gets bigger from there, and then the -7, of course. And so that's how we're doing the domain, is we're just looking at those x values and figuring out, okay, where do they go? All right, now similarly, range is the same idea, except it's looking at the y's. So for doing range here y is going to be less than or equal to 2, because if I look at my y values, in other words, how high is this graph going, it starts up at a +2, and then the graph exists entirely below that y value. So this graph includes all of the y values that are below 2. Basically, domain and range can just be thought of as descriptors of the graph. Now we'll actually be able to put them to a little bit more work later on, but for now, basically they're just ways of describing the graph. Now you saw this example, same different example, you can see how that would show up here. In this case, if I'm looking to see for domain at what x value this graph starts, a lot of times we think of this one right here. But notice we have graph to the left of that and to the right of that. So that's not like the limit about where the x values start. It might be the first point we plot, but it's not necessarily like the number that's going to go in the domain. So in this case, there is no value, because we're assuming that the graph continues off the grid the same way that we're seeing it here. There is no value where our x values start or stop. They go on forever to the left or the right, and so in that sort of a case, this is what we write. We say that the domain is all real numbers. In other words, this graph includes every single real number that there is as a possible x value. The range in this case, though, it's a little bit different. It's not all real numbers, because you notice the graph goes down only so far, and then it goes up again from there. And so we look to see just how low did it go. Well, it went down to 1. And then the graph again exists entirely above it in this case. Now range is always going to be y. Since I'm going above that line, that's why this is a greater than or equal to. And then I'm just saying what number it's greater than or equal to. This 1 here is just whatever that number is there. All right, so that's the basic idea of domain and range. You saw this in Algebra 1. Hopefully this is just a refresher, but just kind of bringing it back, helping us to remember how domain and range work, because it is a skill that tends to get a little bit rusty, and it is going to keep coming up this year, so we need to have that. Some other little details are vertex and axis of symmetry. And so go ahead and write these also down to your notes, and then we'll just practice these things we've been taking notes on in a moment. All right, so you're getting down, hopefully have down or otherwise almost done with the notes here. For vertex, say I describe it as a local maximum or minimum. So in other words, in this general area, this is the minimum value in this particular example. And so that lowest value that it reaches in that area, that's the vertex. And so that's why when you see this listed down here, you see vertex is always written as a point. It's a coordinate pair because it's actually a location on the graphing grid. It's actually an XY location. So we're just grabbing actually what the coordinates of that are. Now we've actually been talking about vertex some as we've been going, so this is hopefully a bit familiar. But one thing we haven't talked much about so far is axis of symmetry. And some graphs have it, some graphs don't. Actually, that's true of vertex as well. Some graphs have a vertex, some graphs don't have a vertex. But the axis of symmetry is the line across which the graph can be reflected but still look the same. In other words, if I dropped a mirror on this graph right here and then looked in the mirror, it would still look like the exact same graph. Because I'm basically taking this side and reflecting it across that line, and when I do so, it becomes this side. It's a straight reflection. That means that that line right there is the axis of symmetry, and notice how that shows up there. Notice the axis of symmetry is actually written as the equation of the line. It's not just -5, it's actually the equation of that vertical line. So it's actually x equals -5. To practice what you just took notes on, please take a look at this graph. It's just a made-up graph. It looks kind of like an x squared, but it's not. It's just a made-up graph. Please list out what the domain, range, vertex, and axis of symmetry all are. All right, so now that you've tried it on your own, let's take a look at the thought processes that we would use in order to be able to get this. The first question is domain. As I look at this graph, I'm looking to see some x value where it either starts or stops, like where it starts or stops going over. Well, it's getting pretty steep as I get down here, but it looks like it's still going outward. It's not becoming like totally vertical and therefore stopping going over. So it looks like it's going to keep going forever out to the left. As I look to the right, it looks like it's doing the same kind of thing. It's getting pretty darn steep, but it is still going outward as we go. Therefore, that's going to include everything. So therefore, our domain here is going to be all real numbers. The range. Here the range is our description of y values. Well, here there is kind of a starting y value. It only goes up so high. And so it only goes up to this line. So this is going to be kind of that critical mark that we're looking at. So range, it's always talking about y, so that's the first thing I put in. What is the y value of that line that I sketched in there? 6. And that's just a visual. You don't have to draw that in yourself. It's just kind of helping us see what's happening here. And is my graph existing above or below that line? Below. Therefore, I write that y is less than or equal to 6. All right, next up is the vertex. Remember, the vertex is like that maximum or minimum value, the peak of it. And we can see that happening right here. So this point is the vertex. I want to go ahead and just give the coordinates of that point then. That is at -2, 6. And finally, I need my axis of symmetry. Remember, the axis of symmetry, that's like where would I put the mirror in order to make sure that it would reflect entirely back onto itself. And I'm looking at that. So my axis of symmetry is going to be the equation of that line. Well, what number is that at? It's at -2. And what equals -2 if it's a vertical line? X. So the axis of symmetry is x equals -2. And that's what we're going to look for. And as you take a look at this, you might be wondering about some patterns that you might be seeing here. Like, for instance, you'll notice that the 6 from the range ended up also being 6 in the vertex. Is that always going to be true? And if there is a vertex, yeah, that will be true. On this type of graph, yeah. What about like this -2 here in the vertex? Is that always going to match with the axis of symmetry? Well, if there actually is a vertex and axis of symmetry, yes, those two will also always be the same. Because what you'll find is that these things are always symmetrical around their vertex. Because that's where it peaks out and starts going back where it was, right? So yes, those are patterns that you can see and that you can actually use as you go forward.